Welcome back, everyone. We are on topic 5. This is moving beyond slope-intercept, and we are on student activity sheet 2, using slope-intercept form. Okay, so in the overview, we talked about connections between constant rate of change, slope of a line, and linear functions. Okay, so let's just do a quick check here. When talking about how quickly or slowly a linear function is changing, we are discussing a function's rate of change. A graph of a linear function forms a straight line. The line is straight because the linear function has what we call a constant rate of change. Remember, we talked about how if it was curved, it would be non-constant, or if it had like zigzag type things, if it flattens out, if it changes from going like a straight line to a different straight line and then maybe another straight line, that would be what we call non-constant. Okay, so either a zigzag or like a curve would be what we call non-constant. So the big thing here, guys, is when we graph a linear function, slope refers to the steepness the function makes. So before we talked about rate of change, if it had a higher rate of change, it was more steep. If it had a smaller rate of change, it would be less steep. Well, that rate of change is the same exact thing as the slope. Okay, the slope of the line, again, refers to the rate of the change. It can be expressed as a decimal, a fraction, or an integer. So here on this problem, what they want us to do is they want us to use the 2 points on the graph. So this came back from the fuel gauge problem that we just did in the overview. And they want us to use the 2 points, 0, 1.5, and 10, 12. So that would be this point down here and this point up here to determine the slope. So what we're going to do is we're going to count how much it takes us to get up, and that's going to be, what kind of here? But I'll go ahead and I'll show you the formula here. Okay, and what this is this means the change in the y values divided by the change in the x values. So let's talk about the y values first. Okay, the y value here is 1.5, and the y value way up here is going to be 12. So I'm going to plug those in, 1.5 minus 12. And then the change in my x value. So we're going to start again with this one. The change right here, that's 0. And then all the way over here, this is going to be 10. If you count them out, that's 10. So we're going to say 0 minus 10. Okay, and when we plug that in, negative 10.5 divided by negative 10 equals a positive 1.05. Let me actually change that. I had the wrong point there. Okay. So what happens when we actually plug this into the formula is the amount of gas in our car starts with the 1.5 here. Come on. Then it increases by 1.05 for every inch that we increase. So let's go ahead and check that and move on. Okay, so again, that turned into 1.05. And then right here, this was the height that the height that we originally started on, which was 1.5. Okay, and what we get with this, that is our equation, y equals mx plus b, where that b right there is our starting point, and that m, the number we put in front of the x, is the slope that we come up with. Okay, so now what I want us to do is I want us to look at each of these polygons. Okay, remember, a polygon is any shape that can be closed off. So with this, they start us off with a triangle, and what they want us to do is they want to draw a diagonal line from one corner to the others. And if you see here, if I to draw a line from this corner to another one, it would just bring me down a side. It would bring me down both of those sides. So that is not considered a shape there. And let's see if I can figure out how to erase that. Okay. All right. Moving on. So when I go ahead and fill these out, you can see I get no diagonals can be made here. On this one, I can make one diagonal across because if I do it to the other two corners, that's just the sides. If I have a pentagon, which is 5 sides, that gives me 2. And a hexagon, which is 6 sides, gives me 3 diagonals. Okay, so we have this table here, and if you flip your page, okay, we have this table over here that just wants us to plug in the number of sides. So we said if there were 3 sides on a triangle, it made 0 diagonals. 4 sides made 1 diagonal. 5 sides made 2. 6 made 3. So they want us to think about, what do we think a heptagon would make? Well, if we counted out the heptagon, you can see on our screen here, if we count out a heptagon, that's 1, 2, 3, 4, 5, 6, 7 sides. So I filled in 7. And if I drew my diagonals, it would give me 4. An octagon has 8 sides. That's like your stop sign. That gives me 5 diagonals. A nonagon, which is 9 sides, gives me 6 diagonals. A decagon is a 10-sided polygon. That gives me 7. Okay. And what I want us to remember through all of that is that these are going to be our X values. These are going to be our Y values. When we're making a table, X always comes before Y. It's just like in the alphabet, X, Y, Z. X always comes first. So now they want us to make a graph that represents the data in the table. So what I did here was I put my number of sides at the bottom. Again, because remember, this is our X axis. And the vertical line over here, this is our Y axis. And so when I look at my table up here, we said the X values is going to be my number of sides. So I put that down here. My Y value is my number of diagonals. So I put that over here. And what this showed me, I followed through here. If I have 3 sides, that means I had 0 diagonals. But if I had a 4-sided shape, that gave me 1 diagonal. 5 sides was 2, 3, 4, 5, 6, and 7, all the way up to 10 diagonals there. So let's flip the page. So they want us to know what is the trend or flow of the data in the table. Okay, and then what can we figure out from the graph? So let's look back at our graph here. Oh, I just lost my lights. Okay, let's look back at the graph. What do I notice? What is the trend? Well, I saw that for every side added, 1 diagonal was added. So again, for every side added, 1 diagonal was added. Okay, so I'm going to go back here. What was my trend? For each side added on, after 3 sides, a diagonal was added. Okay, so now for question 9, it says use the table of data and find a function rule that best represents the line through the data. So what I did here, we said the change in Y. So let's look back up. What is my change in Y? That's 1, 1, 1 from 3 to 4, 1 from 4 to 5, it's 1 from 5 to 6, it's 1, and from 6 to 7, it's 1. My change in X, from 3 sides to 4 sides, it goes up by 1. From 4 to 5, 1, 5 to 6 is 1. All of these are going to be a change of 1. So what I can say is that my change in Y value, remember we talked about how my triangle is a Greek symbol. It means change. It's 1 diagonal divided by 1 side. So what we call that is 1 diagonal per side. Okay, so now that I have that, I know what my slope is. Remember, slope is represented by the letter M. And in this case, we could either write it as 1 or 1 over 1. If you have me as a teacher, you can use either of those. I don't care. You may want to check with your regular Algebra 1 teacher to make sure that they don't want you to simplify that further down to just the whole number 1. Hopefully they're nice like me. If not, you can tell them that they're mean. Okay, so now I have the slope. The next thing they want me to do is find the y-intercept. So what we're going to do is we are going to extend the line, or we can extend the table. Okay, so here what we did, here's where my table started. It started at 3 sides, gave me 0. Well, what if I follow this trend? If I go back to 2 sides, technically, if we follow the trend of a change of 1, that would take me to -1. If I take it back to 1 side, which would just be a line, it would be down at -2. That, again, that's a change of 1. -1 minus 1 gives me -2. And then down to 0 sides, that would be down to -3. Okay, so that's one way that we could do it there using the table. Okay, we can also follow this trend where before we were going up 1 over 1, we can now go over 1 down 1, over 1 down 1, over 1 down 1. And that gives me to the y-intercept. The y-intercept is where it crosses the y-axis. And I see that no matter if I use my table or if I use my graph, that y-intercept is sitting at -3. So if I create an equation off of this, okay, if I create an equation off of this, and I'm leaving my paper here so we can kind of see it, okay, we said y equals mx plus b. Well, we just said up on this page, my m was 1, so I put a 1 in that m spot. And we said my b was -3, so I'm going to put a -3. So my rule is going to be y equals 1x minus 3. So now they ask us, how many diagonals would be in a 20-sided polygon? Okay, so what I did here, using my rule, if you remember, y stood for diagonals, and my x stood for sides. So what I did was they said 20-sided. So I took that 20 and I plugged it into the x value because x stands for sides. So the rule, 1 times x. So 1 times 20 minus 3. So simplify that. 1 times 20 is 20 minus 3. So 20 minus 3 equals 17. So it would be 17 diagonals would be in a 20-sided polygon. Okay, so now they want to know, what does the y-intercept at the point 0, -3 mean in this particular problem? Okay, and what that means is that normally it would mean 0 sides equals -3 diagonals, right? 0 sides, that's what our table told us over here. 0 sides was -3 diagonals, but in real life, that doesn't make sense. We can't have a 0-sided shape. But so what that is, it's what we call the line of best fit. If it continued going in both directions forever and ever, that's where it would cross. Okay. So now on this next problem, I went past that one. Sorry. Okay, so on this next problem, they want to know what is the domain and the range of the function f of x minus 3. And guys, just as a reminder, that x minus 3, remember, if it's single, then you got to put a 1 with it. Be like Beyonce says, single, put a 1 with it. Not a ring, a 1. Okay, so with this, that's a 1. That's exactly the equation that we have up here. So it's the same exact thing. They want to know what the domain and the range are. So when I look at my domain here, okay, my domain, or what are the x values? Okay, this is our domain. Domain, again, always stands for the x values. Well, remember, it goes on and on in both directions forever and ever, meaning I can take these x's out, meet somewhere up here, and that line would still be up there. I can go this way to the left, -, and that line would still be going on down there. So we're going to call that all real numbers. okay? And then my range stands for my Y values, guys, Y values. And so I'm going to look at the Y axis for that. If I go negative, 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 again, that line's going on and on. It's not stopping. If I go up, that line is going on and on. It's going to be, if I go all the way up here, that line is going to make it up there also. So that's going to be all real numbers also. Okay, again, that's not the particular problem with polygons, but for this equation that we just made, that's the case. Okay. Oh, going too far. So now they want to know what's the domain in the range of the function with our diagonal problem. Okay. So if we look at our actual problem that we had created here, remember we started at 3 sides with a triangle and we went to 4 sides, 5 sides, 6 sides, and so on and so forth. Our domain and range is a little bit different. If I look for the domain, that's again my x values. So I'm going to look down here. Where does it stop at? It stops at 3. Well, what do we know about 3? It can't be smaller, but it can be bigger, including the number 3. So we're going to say that x has to be greater than or equal to the number 3. Okay, that's going to be my range. Now, let's look at my that's my domain. Wow. Okay, now let's look at my range. My range in this case, again, is my y's. That's this part over here. Where do my y's stop at? Well, they stop at 0. 3 sides with 0 diagonals. So in this case, my y values have to be greater than or equal to the number 0. So I get my domain of x is greater than or equal to 3, and my range is y is greater than or equal to 0. Because on this problem, we are limited to actual shapes. Okay, again, because we can't have negative diagonals. There's no polygon or shape that has less than 3 sides. So let's do a problem here. So we got Alejandro. He borrowed $1,050 from his grandfather for a down payment on a car. Told his grandfather that he promises to make weekly payments until all the money is repaid. So he made a table to represent the amount of money he still owed his grandfather. So let's look at this table. What is actually happening here? So with this, guys, when he's at 0 weeks, that means that's the initial amount that he borrowed. So 1,050 is our original amount borrowed. And then if we look at each one of these, where they told us in the problem that he's going to repay back each week. So what happens here? It goes down by minus 50. From week 1 to week 2, he subtracts $50 and so on and so forth. So I can tell just from this table that he is going to pay back $50 each week to his grandfather until his debt is gone. So now in the table, we can see 6 full weeks of Alejandro's repayment. So they want us to look at the pattern and write a linear function that we could use to find out how much his grandfather would still owe, how much he would still owe his grandfather after 10 weeks or after 20 weeks or after maybe 25 weeks, okay? So the first thing I'm looking for is my b. Remember, we've got the equation y equals mx plus b. B is our starting point, okay? Where did he start? That's always going to be when x is 0. When x is 0, remember this is x, this is y. When x is 0, he owed $1,050. So my y-intercept is 1,050. And if you want to make a note, when x equals 0. Okay. Now, what was the weekly change? What was the change? Well, we checked it over here. We said he pays back $50 each week. So in this case, my b, my slope, is negative 50 over 1 week. So what is that? It's just negative 50. My m is going to be negative 50. So if I come up with an equation, and if it helps, guys, always do this, fill in the blank. You're always going to have a y and x, okay? where M is the first number. So we said M was negative 50, and it's negative because he's taking it off, okay? And then his intercept, the amount that he started with, was 1050. So now they want us to assume that Alejandro's rate remains the same for several more weeks. They want us to use the rule that we just made right here and plug it in to find out how much it would be after 15 weeks. So remember, my X is weeks. So that 15 weeks is going to go in the X spot. So negative 50 times 15 plus 1,050. And what I get when I use my calculator is I get $300. And guys, just use your calculator to plug that in here. I said negative 50 times 15 plus 1050. And that gave me the $300. Okay, so what do I know? After 15 weeks, Alejandro still owes $300 to his grandfather. So what they want us to do here is they want us to make a scatter plot using the information that we had from our table. We also have our rule, okay? So what I did was I said that in 0, he borrowed 1050 from his grandfather, and we'll just kind of have to approximate this. In 1 week, after 1 week, he dropped down $50 and owed him $1,000. Drop down 50, drop down 50, and so on and so forth. Guys, just try to be as close as you can with this. So that's what our line is here. So now they want us to simplify this equation here. Now I'm going to tell you guys, this equation, it's more than you are ever going to have to do. This is tough, okay? So we have this function. All I did here was I showed you, remember, our distributive property. It's just like as if they were numbers, but because they're letters, we have to keep them all there. So they want M times X, which is MX. They want M times the change in X, which is M times the change of X. And then they have this plus B, so I said plus B. Then over here, we have like a -1 that has to distribute to each of those. So -1 times MX, and I'm going to go ahead and do that, gives me negative MX, and -1 times B gives me negative B. So now what we're going to do is combining like terms. Remember, like terms have to look identical. MX and minus MX, and then plus B and minus B. And that gives me those two cancel out. And then plus B and minus B cancel out. And all I'm left with is that the change of Y equals this value right here, M times the change in X. Well, what they want us to do here, guys, is they want us to get this M by itself. So to do that, I'm going to divide it by the change in X. If I divide by the change in X on this side and divide by the change in X on this side, we end up with M equals the change in Y divided by the change of X, okay? That is the exact same formula as slope. Now, this whole thing, guys, this was just to show you why, okay? But what you need to know is this right here. That's all you need to know from this problem right here. Okay, so now we have, again, this problem that we see on this screen here. They want us to consider the function. This is a new function here, 12x minus 24. Can we find the zero of the function? Okay, can we find the zero of the function? And so what we're going to do here, a zero, first of all, before we can do that, we need to decide what a zero is. So what you guys need to know, a zero of a function is what is X when Y is 0. So here's my Y is 0. Well, what is X? And in this case of the graph, it would be 21. So what we need to do, sorry, this is the wrong problem here. Ignore that. If I plug in 0 to that x here, we would say 12 times 0 minus 24. 12 times 0 is 0, so y is going to equal negative 24. So in this particular function, the 0 is negative 24. Again, that's not what we have on the graph here. It's this problem right here. So so again, I show you this problem here. Okay, just ignore all that. I apologize, guys. So with this function, with this function of f of x equals 12x minus 24, what is x when y equals 0? So here's f of x. Remember, that's the same exact thing of y. We're going to take y equals 0 and plug it into the problem, and we end up with 0 equals 12x minus 24. We need to solve for this x. So this is where our two-step equations come in. We've got to get rid of this minus 24, so I'm going to add 24 to both sides of the problem. And with that, I'm left with 24 equals 12x. Well, I need to divide both sides by 12 to get this x by itself, and I end up with x equals 2. So the 0 of this problem, again, when y equals 0, is 2, 24. I apologize I was going the wrong way, guys.